Integration by parts. Basically, when we were differentiating, we had a product rule. This is pretty much the product rule in reverse. So integration by parts is used when we have a product of two functions. I'm not going to bother deriving it. I'll sort of try and explain it. So like, there's the original function, if you like, and there's the write down the first, diff the second. Over here is write down the second, diff the first, but moved it to the other side of the equation. That's roughly where it comes from. So this is how I tend to remember it. The integral of u to v is equal to uv minus the integral of v du. Now u, because remember we're going to have two functions multiplied together. So we have to decide what is going to be the function and what's going to be the dv, or the derivative. So when I'm looking at the two functions. The u I'm going to pick so that the differentiation would create a simpler function. So a polynomial is usually a good one, because you'll subtract one off the power, it'll become a bit simpler. Trig's a bit tricky because differentiate sine, you get cosine. You haven't really made a simpler function. Same with exponentials. E to the x, differentiate e to the x, you get e to the x. You haven't really made a simpler function. So they're not usually the best choice. Sometimes you're forced to choose those, but if I have a polynomial with it, I'll go with the polynomial. So whichever's going to make a simpler function, if you can. The dv then has to be something you can integrate. Now that might then force your hand on what you choose for the u, because even though the u might be something simpler, if you then end up with something you can't integrate for the dv, I've got no choice, I've got to use that for the u. Because if I can't integrate it, I can't go any further. So here we go, x sine x. Here is an obvious one, because x, if I differentiate that, it will become simpler. It's just going to be the number one. Sine x, I can integrate. Now x I could integrate as well, but if I chose sine x to be u, that's what I was saying before. Well, it's just going to become cos x. I haven't really made a simpler function. So I'll choose u to be x. So du will become dx. Differentiate x, we just get one. It's become a simpler function. The dv is sine x. So if I integrate the sine x to get the v, I get minus cos x. Okay. And so it will become uv, so minus x cos x, minus the integral of v du. So minus minus becomes plus, and it's now just the integral of cos x, and I can go and do that. So the integral of cos x is sine x. Rearranged it so the positive went first, and we've got our answer. Log x. So log x, it looks like it's just one function, but it actually is two functions multiplied together. It's log x times 1. 1 is the other function, because of course we can't integrate log x. This forces my hand because I can't choose 1 to be the u. If we chose u to be 1, when I differentiate that, I get 0. Okay, fair enough, that's simpler. But then that means log x has to be what I integrate. That's the question in the first place. So my hand's forced here. U will become log x. Du then is dx on x. The dv is simply the 1, or the dx. Integrate 1 and we get x. So uv is x log x minus the integral of v du. The x's cancel and I just have the integral of x. And there is that integral of x log x minus x. Now you may remember back when we were talking about integration before, I said this is another one of those missing standard or non-standard integrals. I'd personally just be remembering that one because it comes up a lot, the integral of log x. Integral of log x is x log x minus x. So unless they said find this by integration by parts, well then okay, you need to show you're working out. But if the question simply is what's the integral of log x? Oh, x log x minus x. Let's do a definite integral. Okay, we've got x and we've got e to the minus 7x. So again, hopefully this one's a bit obvious which way. Because if we chose e to the minus 7x to differentiate, well, that's minus 7e. I haven't made it simpler. I certainly can integrate e to the minus 7x, so satisfies that criteria. And if I choose u to be x, differentiating that, yes, certainly simpler, becomes 1. So integrate e to the minus 7x, and we get minus 1/7 e to the minus 7x. So now let's sub it in. We get uv, but now that it's a definite integral, I put my square brackets around it. Okay, we're going from 0 to 1. Minus the integral of v to u. So minus minus becomes a plus. I've also taken a 7th out the front. And we're now just integrating e to the minus 7x. Now, it's up to you whether you want to substitute in straight away or just wait to the final product, because they all are going from 0 to 1 anyway. It's just a matter of choice. Which way did I go? I waited to the end for this one. So integrate e to the minus 7x becomes minus 1 on 49 e to the minus 7x. Substitute in 1, substitute in 0. What a lovely looking thing. Now this one's an interesting one. See, if I choose e to the x to differentiate, I get e to the x. Haven't made it simpler. But I can integrate e to the x. So all right, if I choose cos x to differentiate, I get minus sine x. I haven't made it simpler. Oh well, I've just got to make a choice. Which one am I going to do? Because it really doesn't matter. So which way did I go? I went the e to the x. Why? Because it's the world's easiest derivative. So I thought I'd use that. As it actually doesn't matter which way around you go for this. You'll still end up with the right answer eventually. So du becomes e to the x dx. That means my dv is cos x. Integrate that, I get sine x. So it's uv, e to the x sine x, minus the integral of v to u. Now we just have to integrate e to the x sine x, which is pretty similar to the original question we just had. Oh well, do it again. However, this is the important bit. When I make my choice, am I going to use the exponential, am I going to use the trig, I've got to go with the same one that I did the first time. Because if I go the other way round, I'll end up with one of those circular arguments that'll end up saying 0 equals 0 or something like that. So u will equal e to the x again, du will be e to the x dx, dv is sine x, v will be minus cos x. So it's going to be minus, so minus the uv, so uv was minus becomes plus e to the x cos x, minus v du, but v is minus cos x. So we've got minus the integral of e to the x cos x. That was our original question. But now that's when we look at this as an equation rather than a set of lines. Because what we're saying is this first line is equal to this last line. So I'm going to move the integral of e to the x cos x to the left-hand side of this equation. So 2 lots of the integral of e to the x cos x is e to the x sine x plus e to the x cos x. Well, there you go. Integral of e to the x cos x is a half of that then. And I just chucked in a plus constant because we've got to have it there, because it could be. Always have, don't never forget your plus or constant. All right, handful more of some other ones to do there.